Hi, and welcome back to another tutorial on SQL. In this tutorial, I'm going to talk about creating table using SQL statement and also dive deep into the whole RDBMS applications and how RDBMS application or database management systems differ in terms of SQL functionalities or functions, and then we'll run a couple of examples of creating table using statements. So as you know, database tables in RDBMS, which stands for Relational Database Management System. So what's a relational database? Please refer to my video where I've provided a detailed review of relational databases versus non-relational databases. So again, database tables in any RDBMS is used to store the data in the form of structures or structure forms. And by structure, I mean columns or rows or fields and records. So column is pretty much when you look at a table, column, and let me just open this table for the sake of this example. Uh, Fields are each of these columns, and record is each of these rows. Again, depending on the environment that you work in, you may have different names for the records or rows or for the columns or fields. So SQL language provides a variety of ways for you to query in order to interact with the data in a very easy way. So as you known by now, that SQL statements are also very robust and also very comprehensive. Not only we can use SQL to run queries, we can also use SQL statements to actually create or manipulate tables, or even insert in data, update data within the tables, and that kind of stuff. So before any further details, I'm going to go ahead and start to write the SQL statement for creating a table. And before I do that, I'm going to explain how you can do that manually too. And as you can see here, under Postgres 16, we have the databases. And under that databases, we have the database called Art of Numero. So Art of Numero has one schema called public. And so the public schema has one table called the world indicator, which is the table I've been using thus far to demonstrate SQL functions and statements. So if you wanted to create a table manually, which is could be much easier, is pretty much to right click on the tables and click on create table. And on this drop down, you can give it the name of the table, who the owner will be. In this case, it's the Postgres, and if you want what schema you want to put that table under, right? And all the basic information can be filled out here. But what's important and what I'm trying to get at here is the columns, right? So you have to specify, you have to create and specify columns, unless you want to inherit columns from a different table, which in this case, unless you want to clone or bring the columns or fields from a different from an existing table, then you can do it from here. From an inherited table, then you can do it by using inherited from tables Dropbox here. But if you wanted to actually start from zero and start to create your own columns, then this is where you want to do that. And so when you write the name of a column, let's say you want to put ID, right? It allows you to actually assign it a data type. So data types is very, very important to know. If you come from a statistics background, you probably don't have a lot of familiarity with data types. Maybe the data type with the high level data types that you learn and will be learned in statistics are uh, broken down in categories of quantitative and qualitative, and then quantitative data we or even outside that length of qualitative and quantitative, there are measures, there are measure data type, there's ratio data type, there's interval data type, there's a nominal data type, and there's ordinal data type, right? And so where nominal is like pretty much character or categorical data, ordinal is more like data that has order to them, ratio and interval or numerical data, with the exception that in intervals ratios don't have a meaningful zero, intervals have a meaningful zero, meaning ratio, if you have a zero, it means there is something absent, it represents absence of an item or number. While an interval, zero actually has a meaning. For example, a temperature could be, and is an interval because 0% Fahrenheit or Fahrenheit or 0 Celsius, I should say, does not mean that there's actually the degree of temperature is zero. It actually signifies something that when it's translated to a different measure for temperature, then it translates to a different numerical. That means basically zero has a meaningful position or existence. But when it comes to the databases, this becomes so much robust. It's become so much complex. As you can see, or even with Tableau or let's say R, we're dealing with like a handful number of data types, or even let's say with Tableau, you're dealing with discrete and measures, and then of course the floats and dichotomies, true and false, are there too. Date data type, measures, integers, numerical decimal points, that kind of stuff. I don't remember all of them off the top of my mind, but I'm just saying that things are not as with Tableau and everything else that I've used so far. Things are not as robust as it is with SQL, because it makes sense, because SQL, you're dealing with database management systems, and you're dealing with complex data types. There are a variety of characters. There are a variety of booleans, which is the dichotomy I was referring to earlier for the true and false. Um, and there are a variety of bytes and character variable characters, or fixed length characters, that kind of stuff, dates and double precisions, vectors, so integers. So there's a whole lot of data types that you have to select from, depending on what the needs are or what the requirements are for that specific table that you're creating. But make sure that you have determined data type before writing. And length precision, a scale, and not a null. And you'll see this when I write the statement for creating table. Each of these things, you will see them in the statement. But you can, again, I'm just showing this to you to make sure you know that you can also use the drop down menu to create a table manually. And so now that we don't know all of the data types, and now that at least have an understanding of to be mindful of, to expect a robust set of data types in relational database systems, especially when using SQL to talk to them. So make sure that you're prepared for that. Length precision assigns you, if you want to specify a specific length for that data type. Length precision is allows you to assign, a length, a fixed length, or assign a specific length. Also with the scaling, what it allows you to choose a scale, not null actually. If you have this turned on, then you can leave a cell or for the cell for the ID column. You can't leave any cell blank. You can't have no null. So if this is turned on, then you can't have no null. But if it's turned off, then you can leave cells within the ID column that you're creating as blank. And if you're going to assign a primary key, which You will get to learn a lot more about and additional dependency videos and tutorials that I'll be producing. The primary key is very important to understand, especially if you want to create a relationship between tables, where one table can have a primary key, while other tables can have both primary keys and foreign key, where the primary key talks to those foreign key in the tables, so that you can create joins. There's a variety of joins: inner join, outer join, left, right. So those. And if you have to, in default is if you want to, add a specific default value for that column. All right, so let's go ahead and do this. I'm not going to save this again. This was just for the sake of practice and honest I probably forgot. There's for the data types. I gathered all of these information about data types, and that's why, as you can see, there's a lot of types here listed, and that's why I was mentioning earlier that to expect the robustness of data types while you're working with the relational databases and you're using SQL to talk to those databases. So uh, when it comes to SQL's scripting or syntax. Remember that SQL is a standard language that's we can use with relation database management systems, again RDBMS, but each of these management the database management systems like Postgres or Microsoft SQL Server. So they each of them they support the SQL standard to a very large extent. So that means that so there are many SQL statements and queries that are similar or even identical between the systems. So you don't have to worry about too much, and that also applies to data types. So, however, just because they're identical to a large extent, be careful that there are also some different differences, especially differences that are yeah, that comes from like proprietary type of extensions or add-ons, that kind of stuff that each of these companies have that you need to be aware of, and then they apply those proprietary extensions and features in their products. So you need to be aware of that. So and that also applies to the syntax. So since there are some very few syntax that are like exclusively owned by each of these DB management systems, that you need to be aware of those. So again, a lot of these data types, you will find them common in the data type description of the database management studios, but still I collected these to kind of describe, and I'll have another video where I'll go over the data types in details, but just a quick peek at this MySQL data type, as you can see here. Although the character and variable character, these two are listed under MySQL, but you also see that they're also used in Postgres and SQL Server. So that's why I was saying that earlier, that they're highly identical to a very large extent. Yeah, so numerical data, these are the data types to expect. And when it comes to SQL Server data types, these are what you need to expect. And you don't have to really remember each thing off the top of your mind. It's just as long as you know the concepts and you're familiar with it. And if you let's say if you write a query, if you write a create table query and you use, let's say, a tiny integer, right? And then it gives you an error. Then if you're using, let's say, if you're using MySQL, and then this is something that you see on the SQL Server data types, and maybe you should just go look for it in the MySQL to see if that is different, if that's different from, if it differs, although maybe slightly, slightly, by, very slightly, but there could be difference. That's something that you need to research to find. But it's not very phenomenal or very major for you to worry about, as long as, again, to expect that there are uh, a wide range of data types within database management systems, and that when you use SQL as a standard language, expect to face some very few differences in the syntax of data types, especially when you're assigning data types. And I also have this one here, uh, for the SQL Server and Postgres types mapping, so you at least know, how much. And these are pretty much those that actually have differences. So, like for instance, if you find a difference, in SQL Server it's called datetime, and in Postgres it was called timestamp. Like, float, it's the same. It's called image in SQL Server. It's called byte in Postgres SQL. Uh, so it's called ntext in SQL Server. It's called text in Postgre. Real. So yeah, just review them, and you know, make sure that you're using the right data type when you assign data type to while creating a table, so you don't run into error. You can check. You can do a basic Google search, and there's a lot of good information resources out there that you can use while validating your data types. All right, now let's just go. So now you also know how to create table using the manual feature available within Postgres. And this is something that I also know it's available within the SQL Server with the IDE, the management tool for the SQL Server is MS SQL, which stands for Microsoft SQL Server Management Studio, MSQMS, something like that. So you can also create table using manual drop down menus in Microsoft SQL Server Management Studio as well. So don't sweat over it. If you can't create it using uh, a statement, then you can always create it using the manual uh, you know drop down menu on the GUI, on the drop down menu box. All right, now let's just start with the syntax of creating a table. And so for the we're going to start with create table, and that's what I like about SQL. A lot of the syntax are easily understandable. You just feel like you're explaining something to a person who speaks understands English. So all right, so um, just when you create table, make sure that you know that SQL query to create a table must define the structure of the table. So the structure of a table, as you know, consists of the name of a table, so the name of columns or fields within that table, and then the data types that will be embedded within each of those columns. These are the three important things that you need to know before you even start creating start typing your SQL statement. And also make sure that you know that each table under your database or uniquely named, so they don't share the same name. And so yeah, create table. Let's go ahead and create table. Let's call this table one, right? And once you do that, let's go ahead and start to write uh, the information about the columns that will be used in in and to start writing information about each of the columns that will be created within the table. So we're going to start with the ID. An ID is actually, as you can see here, country ID. This is also a primary key, as you know, because it says PK. So we're going to start with ID, and ID is integer. Mostly IDs are commonly the IDs are integer because they don't. It's just an ID. They don't take decimals. So it's good to keep IDs as excuse me. It's good to keep IDs as integers. So let's see, go ahead. I would say just open the parentheses and then type everything below it. All right, so let's start with ID and then put integer for the data type, and then put not null. So that's just as I said earlier, as I was explaining to you in the as I explained to you on the manual creation, that sometimes that you can that when you create a column, not null actually specifies that it will not allow any empty cell. So we're going to the IDs always need to be not null because you don't want to have a record without an ID. That's not a good idea. All right, so the second one will be name, and so maybe not name, maybe yeah, name. So the name will be we can use a variable character, and we can assign it a 20, and the next one will be the A. Let's just put salary, and let's just assign for the name. We can, as you saw for the name, I did not put not null because I want to say sometime I want to say that I want to specify that it doesn't have to excuse me, it doesn't have to it doesn't have to specify it doesn't have to be a not nullable cell. So if we have an empty cell, it's okay. It's okay to have null for names. I don't know how good how good of an idea that is, but just for the sake of practice, I want to keep one for and I want to keep one as nullable. I don't know if that's even a word. All right, so salary, and then salary, I'm going to put decimal. Why? Because decimals, salary, money. It's always good to put decimals, and decimals or a decimal data type is any data type that you actually allow that you actually allow for that specific numerical data to keep a to keep to have decimal points after the integers. So, and then we're going to select we're going to say for the decimals we're going to select 20 and 3. So it should be 20 uh, uh, 20 indices in length, and then three index length for after the decimal point. So, and then let's just do the last one, and that would be let's say let's just put country, and for the country let's just put second, let me just make a small cap. For the country, let's just put uh, character, yeah. And let me open this. Uh, I have a yeah, for the character, since we're working with Postgres, as you see, it gives us an n, which is the the n number of length that that character should allow. So I'm going to select maybe 25 here. 25 is standard. And then lastly, I'm going to specify. Oh, I forgot to put a comma here. Remember to put a comma after each of the fields that you specify. So I'm going to now put the primary key, and then in the parentheses I'm going to put ID. So our primary key will be the ID. So that's something that needs to be done almost each time that you create a table. Make sure that you have a primary key for the reasons that I explained earlier. All right, so this should give us a table named table one, where there will be one, two, three, four columns or fields, and where ID will be the primary key. It will be an integer. It will be not nullifiable, right? Next one will be a variable character with 20 length of precision, and salary decimals will be a decimal. Salary will be decimal with 20, and then three indexes after the comma for the decimal or after the zero. I think they use comma in like the UK and Europe. The US we use period for decimal points to specify decimal points after a number. And then country is going to be a character variable, and the 25 will be the number of length, and the primary key will be ID. Let's see if that will work. And actually run it for us, so it's good. All right, so Now that we created a table, right, we need to verify that the table was created. So how do we do that? We just need to perform a refresh. We don't see it here now, as you can see. We don't see it. Still, oh, actually, it did go. Oh, it's actually tables. Under the tables, we have one tables and one indicator. So we need to refresh we need to refresh the environment to update the tables. And there you go. Now we have table one. And we click on table one, and we click on columns, you see that we have one, two, three, four columns. We can still run it, but we won't be able to see. We can still run it, but we won't be able to see any data because it's an empty table. So count of rows is 0 because there's no data. Um, Data. Let's do the first 100 rows, and you're gonna see it's going to be nothing. Why? Because there's no data. It's just an empty bucket or empty table that we just created. Um, a couple of things about data types again. The structure of the table when you create it, it contains again table name, table name overall, which is this one, table one. Table, the fields within the table, right? And then what each of the data type will be for each of the fields, right? And then what will be the length that should be allowed for each of those fields. If you want to add any, if you want to assign any precision or length, and then should it be not nullable, meaning can those specific fields be left empty so that it becomes a null cell, null value cell. Um, there's a lot of things. What should be the primary key? Does any of them need to be a foreign key to another primary key in a different table? Those are the sort of things that you need to really think about while creating your table. And it's called table structure. And for a relational database, it's very important to know the most important thing, which is column and row. So column and row is what makes a database relational. Those are two important characteristics of a relational database. The two character variables that we have here. One of them is a varchar or varchar, however we want to pronunciate it. And the next one is just a character variable. So the only difference between these two, although both of them are character-based variables or character-based fields, the only difference is that the character stores fixed length characters, string data types, or character data types, and the varchar or varchar variant character field stores variable length string, where an upper limit of length needs to be specified. However, we specified the limit for both. But CHAR stands for character, and VAR CHAR stands for variable character. And these are the two observations, the two abbreviations that you need to know. So the last thing I'm going to do is I'm going to go back to the query. I'm going to show you how you can create a table using a pre-existing table. And with this one, we created a table from scratch. But instead of creating a new table, we can also copy an existing table and its content, including the structure and a new table. So this can be done using a combination of the create table statement and the select statement. So you'll have to also use the select statement while you're writing the table statement. Um, so again, since its structure is copied, the new table will have the same column definitions as the original table. So it will just copy everything over. And then also the new table will be populated using the existing values from the old table. So it will also bring the values from the old table, not only the structure or the bucket. All right, so let's go ahead and create a statement here now. We're going to start by saying create table, just like for the other one. Now we're going to give it the new name. So I'm going to create a table based on existing table of world indicator. So I'm going to give a new name saying a world indicator like 5555 or maybe 222, three twos. And then I'm going to put as, and then I'm going to come to the new sheet and I'm going to select. So here I'm going to select the specific columns that I need to, or specific fields. I hate this. Each time I use the word column and field and variable, all of them interchangeably, but trust me, they all mean the same thing. The problem is that I've used so many tools and applications that and most of my work in the past have been focused on statistics. So I've gotten used to using the word variable, but when it comes to the databases, with Excel especially, I've always used the word column. But when it comes to SQL, it's field, and sometimes I mix them all up. So, anyways, let's just let me go ahead and put the now I'm going to select all of the columns from the table that I'm going to bring them here. In the world indicator table, there are uh, there are there's country ID, country name, and region. So I'm going to bring these. I'm going to create a table using only three, right? Only three variables here. So it'll be country ID, country, and then region. Just make sure I got the names right. Country name, country name. Okay. And then next, you're going to specify what table it should fetch or should extract, clone those columns from, including its values. And you're going to put the work indicator, which is the donor table. And then if you want, you can also add condition or a where clause to specify what to bring. But if you don't want to do it, you don't have to. Let's go ahead and run this. And so it's telling me that column row has pseudo type record. So uh, I think it has to do with the fact that I'm using the parentheses, which I'm not supposed to. Um, let's see if I can run it without the parentheses. There you go. So the query was returned successfully, and so we have now a new table called indicator 222, where we have borrowed three columns from the world indicator. And as you can see, the table is not here yet. So we just need to refresh the pgadmin environment. And there you go. We have the world indicator 222. And if we run it, we're going to see our new table. There you go. And we can also, again, add, uh, we can add additional, we can add additional, let's say, clauses, conditional clauses here. For example, we can say where the region is equal to uh, Northern Africa. So we're going to create a table with these three columns, but this time we're going to only include Northern Africa from the region. So let's go ahead and run it. Maybe you should call this 333. A whole new table. Successful. Let's go ahead and refresh it. And we should be able to see it. So again, remember the schema. Public schema is public here. So I think I'll do a tutorial on schemas, database structures, and dependencies, that kind of stuff from more like database management perspective. Although I'm not an expert of database tools, but I know enough to apply when it comes to data definition, data query. All right, so let's see now. There you go. It's here now, and let's run a. Let's view the first 100 rows. It probably won't be 100 rows, but there you go. We only have Northern Africa as just we specified in our query. here. Let me just bring it here on this page instead of going to. There you go. All right. So just the last word in this regard. Remember that in general, if you're familiar with SQL in one database system, then you probably find it like easier to adapt to the other and use the same use your knowledge from one database system and onto the other one. But you just need to be aware of the just some differences and nuances. So it's important that for you to review the documentations for that specific database system, and to understand what are the best practices, if there's been any changes with the data typologies, any specific syntaxes, or any specific data type updates that have happened for that system. So just make sure that you are mindful of those differences that can surprise you. This is it. Take care and have a great day.